Assalamualaikum dan salam sejahtera. Hari ini kita akan sambung lagi berkenaan dengan Fizik brain exercise kita. Jadi hari ini saya akan bercakap berkenaan dengan soalan nombor 6. Okey, kita akan sambung Fizik brain soalan nombor 6. Okey, so tak nak buang masa, kita teruslah tengok soalan kita. Okey. Question 6A. At the instance a ceiling fan is switched off, the angular velocity of the fan is 65 radian per second and stop after 9 seconds. Calculate the angular accelerations of the fan. Okay, so what is our keywords? Okay, based on these questions. Okay, there is it. So we have 65 radian per second as our initial angular velocity and stop. Okay, the word stop here means final angular velocity. Okay, since our fan are slowing down until it stop. So for how long? So you are given a time, 9 seconds. Okay, so the first question asking for angular acceleration. So angular acceleration, the symbols is alpha. Okay, so for those that new in my channel, okay, so when we are reading a questions, after we are highlighting the keywords, what we need to do, we need to writing down a symbols to represent that quantity lah. Okay, so let us check. Okay, writing down all our information. Omega naught, which is stand for initial angular velocity, equal to 65 radian per second. Angular velocity final equal to 0 radian per second because of stop. And then your t is equal to 9 seconds, and we want to calculate angular acceleration. Okay, so here is our working. We use equations omega equal to omega naught plus alpha t, since we need to find our angular acceleration alpha. Okay, so rearranging. So we have angular acceleration equal to omega minus omega naught divided by t. So substitute all the information given and make sure all the information must be in SI unit. Okay, 0 minus 65 divided by 9. And using calculator, we can calculate to get our answer, which is angular acceleration equal negative 7.22 radian per second squared. Okay, so why negative? Because of we are slowing down, so we are actually decelerating. Okay, so this is our angular deceleration. Okay, so next questions, part 2. Number of rotation for the fan to stop completely. So number of rotation, so how many rotation that the fan moving before it stop. So actually number of rotation is a angular displacement, and the symbol for angular displacement is theta. But number of rotation is not the SI unit for angular displacement. Okay, and SI unit for angular displacement is radian. So first of all, we need to calculate angular displacement first in radian, and then we convert it into number of rotation. Okay, so here still we have the same informations. Okay, so first we start with our equation. Theta equal omega naught t plus half alpha t squared. Okay, since we want to calculate theta, so we already have theta on our left hand side, so no need for rearranging, just substitute the information. So substitute 65, 9, okay, and then substitute our angular acceleration negative 7.22, which is we already calculate in the first part. So make sure don't forget your negative here. Okay, and then again you have t square, which is 9 square, and then using our calculator we can calculate to get the answers. Theta, which is angular displacement, equal to 292.59 radian. Then but the question asking for how many rotations. Okay, so we need to convert first. Okay, these answers, so we are not done yet. So we have 1 revolution equal to 2 pi radian. Okay, so based from here we can convert it 292.59 divided by 2 pi to get our revolutions. Okay, so we have 46.57 revolution. Okay, so this is the final answer in terms of how many rotations. So revolution and rotation is the same thing. Okay, how many circle or cycle that the fan makes before it stops, which is 46.57 revolution or cycle. Okay, next question, tangential acceleration of the fan if its radius is 50 centimeter. Okay, so tangential acceleration. So please take note, we already learned before this, we learned about circular motion. In circular motion, we learned about centripetal acceleration. And before this also we calculate at the first part we have angular acceleration, and now the question asking for tangential acceleration. So these three acceleration is not same. Okay, it's totally different. Okay, it's not the same, so totally different. So tangential acceleration is a different equation from the angular acceleration, but it's related. And you are given a radius here 50 centimeter. So since you are given in 50 centimeter, so I already converted for you into SI unit, which is our R equal to 0.5 meter. Okay, so let's calculate. So what is the equations for tangential acceleration? So AT equal R alpha. So it's related with angular acceleration. Don't get confused with centripetal acceleration, because of centripetal acceleration the formula is AC equal V squared over R. So this one AT equal R alpha. Actually tangential acceleration is an acceleration that you already learned in chapter 2, kinetics of linear motion. Okay, so from here just substitute the formula, the information into the equation, and make sure everything is in SI unit. So you can have, using calculator, you can get our answers negative 3.61 meter per second square. Okay, so that's it. Okay, let's move on for question 6 part B. A disc of 8.0 cm in radius rotates at a constant rate of 1200 revolution per minute above its central axis. Calculate the angular velocity in radian per second. Okay, so let us check our key point in these questions. So 8.0 cm in radius, so you are given a radius, and then we are given our angular velocity here, which is 1200 revolution per minute, but we are not given in SI unit, so take note about that. And then the question asking us to find our angular velocity in radian per second. So that means the first question asking us to convert the 1200 revolution per minute into radian per second. So we need to convert by answering these questions. And then something that I missed here, okay, I forgot to highlight for you, but you can see it, constant rate, the words constant rate here. Okay, the word constant rate here indirectly means that there's no angular acceleration, meaning the disc is keep moving with the same angular velocity. So when there's a constant angular velocity, means there's no angular acceleration here. Okay, so take note about that things. Okay, so now we're writing down our informations. Again, 1200 rpm, r 8.0 centimeter equal 0.08 meter. Okay, converted into SI unit. So what is our angular velocity in radian per second? So here's our working. So just very simple, 1200 times with 2 pi divided by 60, because of 1 rpm equal to 2 pi over 60. Okay, radian. So radian per second. So that is why when you converted, you times with 2 pi divided by 60, so you get 40 pi radian per second. Okay, so next questions. Part 2, tangential speed at a point 3.0 cm from its center. You notice here, even though you are given the radius, okay, in the questions above, okay, 8.0 centimeter, but the second part only asking you at the radius 3.0 centimeter. So please take note here, you are not supposed to use r, which is 8 centimeter. Okay, so you need to use r equal to 3.0 centimeter because of you are given specifically in this part. Okay, so we need to find tangential speed, which is velocity. Okay, the velocity that we already learned in chapter 2, chapter 6, okay, circular motion, kinematics of linear motion. That's it, the same velocity here, which is we call as a tangential speed. Okay, why speed, not velocity? Because we are focusing on the magnitude, not the direction. So we need to find the magnitude of the velocity itself, but at when r equal to 3.0 centimeter. So writing down all the informations. Okay, and then we start with our equation, v equal r omega. Okay, so this is the relationship between tangential velocity and angular velocity. So no need to rearrange because we already have our v on left hand side. Just substitute the value. So again, I reminded you that your r should be 0.03, not 0.08. Okay, because of specifically the question asking you when r equal to 3 centimeter, sorry. Okay, and omega equal to 40 pi, which is we already calculate in the first part. And then we have v equal to 3.77 meter per second. Okay, so here number 3, part 3. Distance traveled by a point at the edge of the disc in 2.0 seconds. So distance travel. So distance travel means displacement, linear displacement. Okay, this is a linear displacement at the edge of the disc. So since we have the edge of the disc, meaning we need to have our radius, which is equal to 8 centimeter, because of at the edge of the whole disc. Okay, at the disc, at the edge. So meaning we are taking back the radius, which is 8.0 centimeter. Okay, and we are given a time 2.0 seconds. So writing down all the information here, and then let us check our working, which is we start with our equation first, which is theta equal to omega t. Okay, why I'm starting from angular displacement, not directly find displacement? Because of linear displacement, the distance travel itself is s equal to r theta. So this is the equation related between displacement and angular displacement. So first of all, we need to find our angular displacement first, because of we doesn't have any value of angular displacement. So we start our working with angular displacement. So this is our formula, theta equal omega t. Omega is already been calculated in first part, and we already have t, which is 2.0 seconds. So for pi times with 2.0, we have 80 pi radian. So we already have our angular displacement. Now we will answer the question by looking for linear displacement or distance travel. So in this case, we start our equation with s equal to r theta. And from here, substitute the value of r, which is, remember, we are not supposed to use r 3.0 centimeter because of that is being asked on the second part of the questions. Okay, this part are asking you for at the edge of the disc, meaning the whole r, which is 8.0 centimeter. So r should be 0.08 meter, theta 80 pi, which is we already calculated in previous step. Now using calculator we can calculate, and our answer for distance travel is equal to 20.11 meter. Okay, thank you. That's it for question number 6. And for those that missing out my previous video, you can look at for another videos. Okay, previous video for question number 1 and up until question number 5. So we are discussing brain physics exercises. Okay, so bagi siapa yang rasa membantu video ini, membantu anda untuk memahami dan membantu anda untuk mempelajari fizik dan memahami soalan fizik, so bolehlah kongsi bersama-sama kawan, bolehlah share, dan don't forget to like and subscribe. Thank you, jumpa lagi untuk video yang seterusnya. Terima kasih.